Alright, welcome. We're going to do another build today, and I think you're going to like this one. It's a part that students see lying around and they often think it's a speaker. I think that's what they usually think it is. It looks like this. And this is a ultrasonic sensor. What it's going to do is send out some sound that we can't hear, and that sound is going to bounce off a target and it's going to return. And this thing will be able to measure the length of time it takes that sound to leave and return. And that sound, of course, is traveling at the speed of sound, so this happens really rapidly. So on the back here we've got 4 pins, 2 of which are the ground and the power supply. Those are pretty much standard. The other 2 is a trigger pin and an echo pin. And it's the trigger pin that we're going to use to trigger the release of this sound, and the echo pin is going to measure that time. So the trigger pin is going to be an output. We're going to tell it to start, and then the echo pin will be an input into our Arduino, and it's going to record that time. So it's pretty straightforward. Alright, let's switch views and move this out of the way just for a moment. I'm going to focus on the camera at this point. Let's do our wiring, and then we'll go to our code. So let's go ahead and grab our breadboard. I'm going to use the center, press it in gently there. So we got a good platform for our sensor, and put the Arduino back here. Let's go ahead and work our way across from this side over to this side. The first one is the ground pin, so I'll press that in there and find the ground pin on the Arduino like that. Next one over is the echo pin. I think I want to do green for the echo pin. The echo pin's feeling a little green. Let's make sure it's that one. Yes, the echo was the second one. Let's make the echo pin I'm going to do pin 9. No, 8. I got it in 8. Right there in 8. So that echo pin is going to remember how long it took. And then the trigger will make pin 7. And then we need a little power. Juice things up, and we'll swing that wire all the way across to the 5 volts like that, and we're good to go. So the wiring is fairly easy, and the code is actually pretty easy too. Alright, while I'm thinking about it, I'm going to plug my USB into the Arduino. I don't have to worry about that. And the cord wants to yank the Arduino off my desk, so let's leave it like that. Alright, let's do some coding here. Open this up. So the first thing we're going to do, in no particular order, actually this is a particular order, we're going to attack that trigger pin. We want to turn on. We want to say, okay, go ahead and send out some sound. And to do that, we have to send out a signal, and the signal is going to be off, on, off. Once it gets a signal of off, on, off, then it will start to send out a little pulse. So let's go ahead and do that. Since it's a digital 0 1s, and we can simply do a digital, I can spell right here, digital right. Alright, now we're going to have to tell what pin. I could just throw in, it's a trigger pin that we want to send the signal to. So I don't want to just call it, I could just use the pin 7, but I think we're going to be using that pin for a couple other things. So let's go to the top and declare a variable. We'll call it trigger, and we'll have that equal to be 7 in reference to pin 7. So now I can say, alright, pin 7, I want you to be low. I want you to be low just for a very tiny amount of time will be fine. I don't want there to be any confusion by having it be on below for too short a time. So we'll give it a little bit longer. And now we got to have that pin, which I just declared, and I didn't even use what I declared it as, which was trigger. We want it to go high. Give it a little time. About the same amount of time would be great. And then digital right trigger low. Alright, so that's all we need to get to turn on this sensor to whenever it sees this pattern right here, then it'll send out a little ping. There's a couple little things we kind of passed up. Since let's go back and fix them. First thing is, I'm going to throw this in here, the serial begin, because I want to see this number that we get off the echo pin, so we're going to need that. We're also going to need a pin mode because the trigger is going to be an output pin. So let's make that an output. Let's tell Arduino expect that to be an output. And not the trigger, we haven't made the pin yet. So let's go up here and let's declare a new variable, an integer, for the echo pin, and that was pin 8. That looks pretty good. Pin 8, so the echo pin, we're going to be collecting information from that into the Arduino, so it's an input pin. Alright, that looks pretty good. So we sent the signal out, it's bouncing back, and now we have to collect the time. And let's go back up here, do one more variable, and this will be the travel time. We'll store how long it takes as a travel time, and remember that this is going to be, the time is in, you don't need to type this in, is in microseconds. So that's a millionth of a second. We're going to need to remember that. Alright, so this is the only new part, and that is how do we get that time from the echo pin. And there's a function we're going to use for that, which is going to look for how long it takes to go from a high to a low, and that is pulse in, and we're going to read the echo pin, and we're going to read how long it takes to go from high to low. We want to store that as the travel time. Alright, so we send a little signal to say, alright, sensor, send out a pulse, and this part is going to grab the time it takes for that pulse to come back, and it's going to store it as travel time. And then we want to peek at it. Let's do a little delay again. A little delay. I don't know, let's just go about that long, and then we want to take a peek at it, see if everything's working. And what do we want to peek at? We want to peek at the travel time. Anything we missed? That looks pretty good. We've got some variables we listed throughout our program. We turned it on nicely there, and then we're going to collect the time. I think we're okay. Okay, let's go ahead, and if we mess something up, we'll find out, I suppose. Give it a moment, a little cat break. You have him like right there, so he's peeking over the edge. You can like be our little friend joining us. Alright, looks like it is almost done. Green line's coming out of my ear there. Come on, you can do it. There's a long delay means there might be something unhappy. I'm going to peek at the tools. I did not see Arduino be COM 18 or on COM 3, so this is probably going to fail because of that. I didn't check that. Alright, my friend, I think we know what's going to happen. Go ahead and give us the bad news. I'll just switch it. Just start going with this and resend it. Just try to get it to crash and stop. Just stop looking. We didn't mean to compile this. I just wanted it to stop. We haven't compiled in a while, though. I'll remind you what that does. This check right here, it just looks over our code and looks for errors. So it says, hey, I'm done compiling. I don't see any errors. Everything looks pretty good. This one, of course, here verifies. I don't know if I used the word properly when I just described that one. The check verifies. Make sure our code is there isn't any errors. This one verifies and compiles. We'll look over the code and then it will translate it into what the computer understands. So I don't like that it's yellow. There we go. Finally. There's our error message we were waiting for. Problem playing board. Yes, we knew that. We knew that. And let's switch. Alright, it switched. So let's try it again. This should go a little faster, hopefully. Maybe I just jinxed it. Uh-oh, I don't see anything going on down here, no bar. It's acting like it's going super slow. We don't want super slow. Oh. Let's take a look. Alrighty. About 271. You're going to want to do this as well. I'm going to take this box, give it a nice target to shoot at, and I'm going to place it just some distance and slowly move it in and see if the numbers actually drop. Alright, that looks pretty good. I'm feeling good that we've got everything set up nicely. And I'm going to keep going a little further away. Goes up. Alright, now I'm using this box because I want this sound to bounce off and go, have a lot of that energy heading straight back to the sensor. If I use some irregularly shaped object, it's going to disperse and cause problems. So a nice flat box like this will work great for that. Okay, so if I can let everything stay there. Alright, now the fun part begins. This is probably the only complicated part. This is nice that it's taking roughly 300 microseconds to send out some sound, have it bounce off and go back. But it'd be more interesting if it told us the distance between the sensor and the box. So we've got to convert the values we see up here into a distance. So to do that, we got to use a little bit of math. What am I going to do? I'm going to move my box temporarily and just use this surface to do just a little bit of math. Actually, the first thing we do to help us will not require much math. I'd really like to take this microsecond part out of it and just make it seconds. So let's break it down into a couple pieces, and we can do that right here. Let's take the travel time, and I'm just going to call it travel time. Use the same, but I'm going to take the old travel time and divide by 1 million. 1, 2, 3, 4, 5, 6. So if I divide by 1 million, this should take the echo time in microseconds and then spit it back out into seconds, which is what I should see right here. So let's take a peek at that. This will save us a little bit of math. At least half of it will be gobbled up by that part of the problem right there. So now our time is in seconds, and microseconds is a tiny, tiny amount of time. So we should have 0. Nice. Nice, Mr. Brower. So small amount of time that it's 0. That is because we have defined travel time as an integer, and it's just rounding it to 0. So I can't do my little trick here. I'm going to call it, we'll go and do seconds, rename it, and then instead of declaring it as an integer, I'm going to use a float, and the float will allow it to be a decimal number, and we'll label as seconds. So we'll collect the time from the echo pin, how long it takes to go out, hit the wall, and come back, divide that by 1,000,000. So now it'll be in seconds. And I wanted to see the seconds. I want to see the seconds. So let's try this one more time. Hopefully this works. And we're halfway there. As far as the math goes. This will do the math, half the math for us. Uploading. Done uploading. Tiny number. Ooh. Well, do we assume that's still there? But stretching my memory on float, I do think float does keep 2 numbers out. This will be fun. Let's do this together. Let's look up some data types just for a moment. This will be educational. Let me actually just open up one right here. Let's look up a data type and see if we can get one that'll grab a bunch of zeros. Long looks like it would be a good one. We can look these things out real quick. Maybe here's the integer one we've been using a lot. A little lag here. Come on. Actually, I'm not too impressed with where we just went. Let's go out of here. We've got some weird lag going on. Come on, do something. We'll just bail out of that page. Maybe. Something trying to load. It's that little circle there is struggling. Fell out. Start over. I was looking down the page and I saw long and it reminded me of I'm going to go long. I have a memory of long, using long before. So here we go. Long variables of 2 million. No, that's higher than that. That's a trillion. We don't want to go that direction. We want to go. We want long decimals. We want decimals. Let's do decimal. Try to find a decimal here. Okay, maybe this is a dead end. Maybe I'm taking too much video time here. I'm getting that video time spider sense, excuse me, saying you're spending too much time looking at this. How about this? We'll come back to it. I'm not convinced that just because all I'm seeing is zeros here, that the numbers aren't off to the side a little bit. I'm not convinced that we're actually at a time of 0 all the way across. divided by a million, we're going to take, our number should be 0.000 and then some numbers. That's what I'm saying. So we'll work through this. Let's just go on and finish our little formula here, and then we can backtrack if we need to. If we find that the second data type is a problem, we can incorporate this into our little formula I'm going to show you right now, which is that V equals D divided by T. The speed, which will be the speed of sound for our case, any velocity, is going to equal the distance divided by the time. It's kind of like miles per hour. And so how fast is that sound going? It's going, 1,000 miles per hour. And we can find the speed of sound, and we know our time. This is what our echo is giving us. So all we have to do is calculate the distance. So we do a little algebra and multiply both sides by t. They'll cancel out, and we'll get d equals time multiplied, put parentheses around it, multiplied by velocity. This is what we want. We want to take our time and convert it into a distance. So we're definitely going to want to look up the speed of sound. So let's go ahead and do that. That number we got to input. Speed of sound. Now we have some choices. A little default one came up. This says speed of sound, feet per second. If we choose this one, then our output in our little formula will be in feet when we're done. This will be feet per second multiplied by a time, which we'll get into seconds, will give us feet when we're done. I think that'll be okay. I think measuring the distance with this sensor in feet will be fabulous. So let's look that up. All right, so the value for our speed is 1,125 feet per second. Okay, this is what we're going to input for here. And we're going to multiply that by our time. And let's set that up. Let's kind of toy around with that on our program. So this is theoretically our time in seconds. So let's pretend like it is. We'll run a little formula, and then we'll find out. If not, we can add this part to our formula. So we don't need a delay in there. Let's go in front of the delay. We'll need a new variable, I guess, which will be the distance. This will be a real good one for float. This will be good for float, because we don't care that it's in decimal. We'll keep some of that decimal, but it's going to be a value. It's in 2 feet, 1 foot, half a foot, that type of thing. So that'll be fine. Floats can handle that. That'll work nicely. And what did we want to do? We wanted to take that time, which was not the time but the velocity, 1,125. We don't need units or anything. We want to take that and we want to multiply it by our time, which is seconds. That should do it, right? Except that this is the time to exit, bounce off the wall, and return. So if we want to measure the distance from here back, that'll be great. But I'd like to just measure the distance out to some, I want to point to something and say, have it tell me how far away it is, not how far away it is and coming back. So we got to cut this time in half. Whatever time we get, we got to divide it by 2. So let's throw that in there. Hope that makes sense. Alrighty, let's put distance in here. What are the odds that we will do this a fabulous job the very first time? Let's find out. Our output should be in feet. Now the distances here are pretty tiny. This is like, I don't know, 4 inches. I'm really close to the edge of my table here. Actually, if I go this way while we're waiting here, I could probably hit off something like that. I have my box over here, and we'll hit my box off that way. Okay, it's done. It's waiting for us, and we're at the 0 problem again. Alright, so let's go back and fix that by, we're going to skip this whole thing, I think. Let's do our dividing right in this line. I know this is getting a little nasty here, but let's go back. Travel time. We're not going to do this converting right there because Mr. Brower cannot remember the data type. I don't want to waste a lot of video time doing that. And we're already dividing by 2, so now we're going to divide by 2 million. That should work. So this is the raw data in microseconds. The 2 is because we're dividing that out and back, and the million is because it's in microseconds. We want it to be in seconds. And then we're multiplying that whole thing by the speed of sound. That's in feet per second. So the seconds, this seconds, and the second on that will cancel out, and we should have a distance. Let's give that a try. I think we have a slightly higher probability of this working. Did I actually keep the seconds? I did. Doesn't matter. It's still there. It's not going to hurt anything having that line in there. Alrighty. And we're still a bunch of zeros. What is going on here, Mr. Brower? What is going on here? Something else is going on here. Think for a minute here. Let's just for a minute. Let's go back to here. Back to travel time. Reload this. See if my wire didn't get bumped or something like that by moving everything around. Maybe we just lost the signal entirely. Do a little troubleshooting. You get a little bonus on this video, a little bit of troubleshooting. Nope, those are the values, so that's good. So it's not that, it's our little formula here. And I'm gonna get rid of that just because. And that is our value. We looked that up. That was feet per second. I'm feeling good about that. There's our time from there. It'll be 600 or whatever it was. 500 something. Divided by this big number. And distance, we're using float. I don't have a problem with using float either. I'm just going to throw some parentheses around this. You're probably staring at me saying, oh, this is what it is, Mr. Brower. How come you can't see it? I don't think the parentheses did much. I could have yanked that part off and multiply by that. And just do this a tiny bit at a time. I don't know, I'm not sure. Now we're back to that float part. I like using floats though. We got a mystery. Just for giggles, let's just take that off the end there. I got formula up in little pieces here. Try to diagnose this. Error. Probably because I hit that before it was done. Yeah, probably because I hit that before it was done. That didn't change any. Look at this error in the bottom I saw. That's going to be a big number, but that's okay. Uploading, done uploading. Alright, why are we getting a big negative number? It's fluctuating. Why is it doing all that? That's weird. Oh, I bet it's right here. Is that it? I bet that's it. Maybe that's it. I vaguely remember that if you are using floats, and if you don't have, let me just, before I say anything. Try this out, and then we'll see if that was doing it. Okay, and bam, okay, that looks much better. Yeah, okay, well let's, before I say anything, let's go ahead and add that divide. Then I will tell you what popped in my head there at the end to save us. Come on, you can do it. Alright, little cat power. Energize us there. Had a little troubleshooting for a few minutes. We can do it. And 0.33. Is that 0.33 feet? I've got a ruler over here. That should be about 4 inches, right? The box is just off the screen. You can't see if I go off the side on that side. I'll try not to move the box. I'll try to slide this underneath. And what do you know? Look at that. That's 4 inches. Now from my view, this is heading straight down over the 0 mark. On yours, it's kind of tilted up on the video. But that really is set on that end. It really is. The edge of this really is next to the 0 on our inch, not the edge of the wood where that long mark is. So that is fabulous. Alright, let's go back. I cannot believe I forgot that. But that's okay. This 0 here, when we use a float, we have to, our numbers that we put in our formulas, they have to, you have to put a point in there because we're using decimals. That doesn't explain why this one did not require that. That is weird. That's like counters where I remember looking this up or using it for some other projects using floats. And I remember having to do that, but on this number I didn't have to do that. Let's go back and look again. Yeah, we're happy with these numbers. Just move this, Go closer. To 2. I can't show you the whole foot though. If I go all the way a foot, I'll move this all the way to a foot. It should be about 1. And there it is. So our formula is working fabulous. It's like dead on. Move it up to 0.5 or 6 inches.
Mrs. Sandal, please take the phone call parked at 24.
Half of that is 3.
Sandal, please take the phone call
and so on. That's working great. And it was all because of the 0.0. But why do I not need a 0.0 on that end? Well, greater minds than mine, obviously. We'll have to solve that problem. I'll look into that on my own time. But alright, okay, so I think we've got it done though. The formula wasn't too bad. Had a little trouble with me remembering floats. Should I do a recap? Looking at that troubleshooting. Everything looks good. I think we'll end there. We're going to do a little follow-up with this. I'm going to have you combine the, as part of this project, part 2 if you will, or I might make it a separate assignment, but it's definitely going to be the next one you'll do after this. You're going to combine this with a servo, and as you change the distance here, it would be really cool if we could read that off on an analog output. So this is a digital output what you see on the monitor there, but it would be really cool to have something, I'll try to simulate it here, that tilts like this and tells us how fast or slow it's, or not in this case fast or slow, how far away it is. So for example, maybe I'll redraw it right here. We'll have something like this, where this is 0, this might be 1 foot, 2 feet, 3 feet. Pardon my chicken scratch on there. So we'll use a servo to say, all right, we're at 0 distance, and then as we move the object away 1 foot away, the servo will turn it to 1 foot away, and you can read it off, this analog read. And then when it's 2 feet away, it'll be right there, and then 3 feet away. So we'll have to construct a little cutout with these numbers on there in front of the servo. I've got some cardboard. We should be able to do that. So that'll be a nice extension to this. All right, fabulous. Well, that is it for a slightly extra long because it's a troubleshooting, but let's call it a day, and we'll see you on the next project.